Welcome, this is section 1.4 and we're talking about solving absolute value equations. So in the last section we looked at solving just plain linear equations. Now we want to talk about what happens when we put an absolute value bar somewhere in the equation, how we have to go about solving it. We have to do a little bit different things than we did in the last section, but that's only because of our notion of what an absolute value is and what those two special bars mean in an equation and in an expression. So let's start by reviewing that. Okay, so you saw probably in Algebra 1 absolute value symbols. And the absolute value symbol represents a number's distance from 0 on the number line. That's a key word that I'm going to underline, distance. So we're not really talking about the value of the number. We're talking about how far away on the number line a certain number is from this point 0. Okay, that's important because that's related to how we're going to end up solving absolute value equations. Okay, and the reason why I say it's important is you probably have worked with distance maybe in science class when you're dealing with labs and you're measuring things. Is distance ever a negative number? Like, would we ever say the distance from Pennsylvania to the shore is negative 150 miles? No, we would only ever use a positive number. Right? Well, absolute value is the same way. We would only ever have a positive absolute value. That's going to be really important when we get to equations. So just a couple trivial examples down here of how to take an absolute value. I think you all remember this. So the absolute value of negative 5 is 5. And the reason is because on the number line, negative 5 would be 1, 2, 3, 4, 5 units away from 0. The absolute value of positive 5 is also 5, because again, on the number line, 5 is 1, 2, 3, 4, 5 units away from this 0 on the number line. All right, so let's talk about now what happens when we have some variables in our absolute value bars and how we solve it. So here's a couple examples. The key idea is right here in this bullet. So you might want to make note of that on your note sheet. The goal is always going to be two equations. And the reason why we're splitting into two equations kind of goes back to what we saw on the last slide. So let me just page back a little bit. Do you notice that there's two numbers that are 5 units away from 0 on a number line? This one, negative 5, and that one, positive 5. So the same thing's going to happen when we go back and look at an absolute value in an equation. There's really going to be two things that are 7 units away from 0. And what are those two numbers? Well, the first one will be 7. So the first equation we always write is the same, but we drop the absolute value. The second equation we write, we drop the absolute value, but we have to make the right side negative. Because on the number line, 7 is 7 units away from 0, but so is negative 7. All right, so now we can solve each of these equations independent of each other. 5, divide both sides by 3. So one answer is x is 5/3. We'll go over to the other side. Divide by 3. X is negative 3. So there's actually two values that make this equation work. Positive 5/3 and negative 3. Now take a look at the second equation down here. The absolute value of 4x minus 6 equals negative 2. Think about what we did in the last slide. And I'm going to go back and just look at it again. Think about these two questions. Think about that equation. Will the absolute value of 4x minus 6 equal negative 2 ever? No. In fact, this equation is no solution. I don't care what you ever put in for x on the left side of this equation, you're never going to get an absolute value be negative 2. Because remember, absolute values always are positive because they are distance. So anytime you see an equation like this, you can automatically, for free, because of what absolute value means, write down no solution and move on. All right, now, Let's look at some more complicated absolute value equations. Now, if you notice, the first couple we did, the absolute value bars were already by themselves. But now we're in Algebra 2, now we want to get a little bit trickier, so sometimes I'm going to embed the absolute value in a bigger equation like we see here in this example. The key is, before we can split up into two equations, we've got to isolate. So this is saying 2 times the absolute value of 3x minus 1 plus 5 equals 33. So we got to get this all by itself. So we'll do everything we've done before to do that. We'll subtract 5 from both sides. And then that's going to be 28. Then this is 2 times, so to undo that, we're going to divide by 2. And we get the absolute value of 3x minus 1 equals 14. All right, so now we'll split and rewrite into two equations. Add 1 equals 15. Divide both sides by 3. X is 5. Now we'll go to the other equation. We get 3x equals negative 13. Divide both sides by 3. And x is negative 13 over 3. Okay? And again, you can check this by plugging back in, and you're good to go there. All right, now, here's where it gets a little bit trickier. This concept. And you have a spot in your notes to put this definition. This is a vocab term. You probably saw it in Algebra 1. We're going to be dealing with it a lot. It's going to come up a lot this year when we're talking about special kinds of equations to solve, and this is the first example of it. So when you solve absolute values, it's critical that you check your work, because sometimes we're going to get an answer that works algebraically because we dropped the absolute value bars. But when we go back to the original problem that contains the absolute value, sometimes the answer won't work. And when that happens, you have a thing called an extraneous solution. So that's the definition I have here. A solution of an equation that is not a solution of the original equation. And the reason why that happens sometimes is because we have to take that little liberty of dropping the absolute value bar. So we're actually changing the problem into something that wasn't originally given to us. So we have to make sure that it works for both equations, the with and without the absolute value bar. So here's an example of that. The absolute value of x minus 1 equals 5x plus 10. Our absolute value already isolated, so we can jump right into writing our two equations. First one is what we already see without the bars. Second one, we drop the absolute value bar and we make the entire right-hand side negative. This is key. We've got to take the entire right-hand side because there's two terms here. You've got to actually put a negative in front of the whole right-hand side. All right, let's deal with the left problem first, though, because that's the easier one. We'll bring all our x's to one side. Okay, we'll bring our numbers. Divide by by positive 4. The answer, however, will be negative 11/4. Okay, now we'll go over to the other side. First step, I got to take this negative and distribute it into the right-hand side. So before I do any moving around, that's my new right-hand side, negative 5x minus 10. All right, now I'll bring the 5x over to the left. I'm skipping steps to save time. I'm going to add 1, and I get negative 9. Divide negative 3 over 2. All right, so now I need to check for extraneous solutions. So I've got to put both of these numbers back into this equation. So let's do that. We'll start with a negative 11 over 4. So I've got the absolute value of negative 11 over 4 minus 1 equals 5 times negative 11 over 4 plus 10. Okay, the left side becomes negative 15 over 4. The right side becomes also negative 15 over 4. Well, is that true? I don't think so, because remember, absolute values can't be negative. So this is an extraneous solution. All right, now let's check this one to make sure this one works. Usually there's only one extraneous solution in absolute value problems, if there is one at all. So my guess is, since the first one didn't work, This one probably will, but you never know. Okay, so this side becomes negative 5 over 2. This side becomes 5 over 2, because this is negative 15 over 2, plus 20 over 2, because that's how we can rewrite 10, so we have like denominators. That works. So there is really only one right answer, and it's this one, negative 3 halves. Negative 11 fourths was extraneous. Okay, let's look at another one. Same idea. We already have this isolated, so we can already start to write our two equations. Second equation, remember, since we have more than one term on the right-hand side, I got to put parentheses around this whole thing. All right, so let's bring letters to one side, numbers to the other. X is 1. All right, let's go to the right side. We'll distribute our negative sign. Negative 5, divide by 5. X is negative 1. So we have 1 and negative 1, but let's check them to see if they work. So we'll put in positive 1. I get absolute value of 5 equals 5, and I agree, that's true. Now we go over here. I get the absolute value of 1 equals negative 1. So that's out. So one answer, positive 1. Okay? Last problem for this video. This is probably as hard as it's going to get. This is a mess. The reason why it's a mess, and the reason why a lot of students can get this a little bit tricky and get tripped up, and that's why I'm putting this on the video, is right here. This 6 minus 3. They read it from left to right, and they think, oh, that means that we subtract first, and it's 3. No. This is saying 6 minus 3 times this whole thing, absolute value of negative 8r minus 9, equals negative 15. I need to get just this alone. So first thing I want to do is I want to actually subtract just the number 6 from both sides. Now I get negative 3 times the absolute value of negative 8r minus 9 equals negative 21. Now I'm going to divide both sides by negative 3, and I get negative 8r minus 9 equals 7. By the way, another thing that students get a little bit messed up with problems like this is they see in the beginning a negative 15, and they stop and they say, well, Mr. Wisniewski, you can't have an absolute value equal to a negative number. You said that earlier in the video. This has to be no solution. Not true. It's only no solution if when you isolate, when you get to this step, it equals a negative number. But notice, because we divided the right-hand side by a negative 3, negative 21 divided by negative 3 becomes positive 7. So just this absolute value piece equals a positive number, and that's okay. It should. So you are going to get two answers like we have been getting throughout the video. All right, so let's split up. All right, negative 8r equals 16. Divide both sides, we get r is negative 2. Add 9 here. Negative 8r equals 2. R is negative 1/4. Okay, and we can go in and we can check this. I don't have really room on my slide, but they do both work. You can check it on your own to practice. So we have two answers. R is negative 2, and R is negative 1/4. Okay. With that, you have some practice problems that I want you to try related to all of these problems that we've discussed in the video. Feel free to rewatch any section that was a little bit confusing the first time. And with that, we'll talk more about this in class. Have a great evening. Discard.